Now let's link our various components together to design a highly scalable platform. For the video uploading, a user would interact with the video upload service via the application backend. This service will be storing the video meta in MySQL. Since video uploading would require authentication and authorization, we can have a dedicated user management service which will handle this along with storage of users' data. Then we decided that we'll be processing video asynchronously via a Kafka queue. The content will be consumed via a file chunk service which will process the video further in various chunks. The retrieval of these chunks would be optimized with the caching service which would further cache and interact with global or local CDN. The chunks will then be stored in a file system such as HDFS or S3. Each chunk will also require encoding and compression service before being stored. The chunk service will communicate the processing status to the uploader via a notification service. The Kafka content can also be consumed by various other services. Since each video will need some thumbnails to generate, we can have a thumbnail service which would generate these and store it in an image store such as Bigtable, which is quite efficient for storage and retrieval of images. These thumbnails could also be cached via the cache service. Another service that could help is filtering service to keep the adult content in control for the platform. The status for this can be communicated via the notification service as well. Now to design the video streaming service, a viewer will have an open WebSocket connection with the video gateway to send, offset and retrieve video chunks back to the viewer. The gateway will interact with the watch service while we fetch video chunks sequentially from the file chunk service. Since some videos can be private or could require user authentication, it will interact with the user management service as well. Each request in the service can be used by various other services for different purposes. So we can send each event to a Kafka queue, which will be asynchronously consumed by services like history storage or for analytics purpose. A recommendation engine could also use this to improve further recommendations. The file chunk service will retrieve the chunk from the file storage and cache it on global and local CDN for faster retrieval when some other user watches it. Now coming to the design of searching video, a user will interact with the search aggregation service, which will query and aggregate all the results from a distributed search service. The aggregator can further query thumbnail service since each result will need a thumbnail to be displayed to the user. The thumbnail service will internally retrieve the results from the caching service and Bigtable. The search service will internally retrieve the results from database servers where the indexed results are being maintained. It can further publish the search events in a Kafka queue for other services to asynchronously process them, such as for analytics purpose and recommendation engine. It will also publish the search results to CDN for faster retrieval.